All right. Oh, it's the wrong one. What I got to show you is, let's graph a system of inequalities. So, what will be a good example here? Maybe number 14C. Hello. Oh, you like the bad guys from Harry Potter? Boo. Boo, Slytherin all the way.
Slytherin, I agree.
I don't like that movie because this really awesome guy who's just trying to follow in his father's footsteps gets bullied by these three criminals the whole series. And then Dumbledore just he just lets them win that game. Am I right?
Yes.
I'm right. James, this says, go to the office between classes.
Sounds good.
Yeah. Can you believe what they did to Draco? Drake, yeah.
Drake the rapper?
Okay, yeah.
Yeah.
Those dang Gryffindors, they just bullied him every opportunity.
Gryffindor more like Griffin dumb.
Yeah, they were purebloods.
You know, in the book, Draco was 11 in freshman year of Hogwarts. But in the movie,
How do you know this?
The actor was like 12. Like, come on.
I haven't seen or read any of it because I got bored.
Sean, how do you know this?
Okay.
Because when you're 11, you get shipped off.
The idea here is actually very simple. It's just, if this was by itself, you could shade in the sort of region of points that satisfy that. Oh wait, I missed my attendance. Was Seth already marked? Oh, sorry. He did?
Umbriaco? Yeah, he's out of this batch.
Oh, okay, that's why he wasn't on the attendance. What? No! Seth went the way of Victoria. No.
He
just got
that canceled.
He wanted to get out of school early.
Oh, fair enough.
Oh,
Okay,
yes,
so what you would do is, let's just treat them both separately. You're probably not going to do this for every question, but for the first one, here's how you might do them separately and then combine them into the final answer. So this first guy, what does that look like? Well, you first graph the, by the way, how do you graph that if it's an equation? If it was y equals x squared plus 2x?
I'm not sure.
You know what shape it is.
Right? Wow.
Parabola.
It's a parabola.
Parabola.
And then you'd say, I know it's a parabola. If I can identify the two zeros of the parabola, I can graph it easily. So if you factor out the x, right? See what I'm talking about?
Yeah.
Where does this thing touch the x-axis? At 0 and at -2. So it's a parabola. It's also not too tricky to figure out that the vertex of the parabola is at -1, 1. Meaning you just plug -1 in, the y value is -1, right? Everyone okay with that?
Mm-hmm.
Now, of course, it should be a dashed line because it's just greater than, not greater than or equal to. And then are we above the parabola or below the parabola? Yeah, we're above. There's two ways you can figure that out. One is by testing out a point. So plug in a point like, I don't know, 0, 3 or something. You plug in 0 for x and 3 for y, like true or false. 3 is greater than 0 squared plus 2 times 0. That is true. So therefore, this zone is the zone that satisfies this. But wait, we're only halfway done, right? We also need the set of points that satisfies this. Okay, so we know what that graph looks like, right? There's y equals x plus 2. Are we below the line or above the line? We are below the line. Again, you can test out a point, or you can just go, well, my y values are lower than the x plus 2 line, so that tells you you're going below. All right, now the actual answer, though, is we need the set of points that satisfies both. So I think, guys, you're probably going to typically not do this. You're probably going to get them both onto the graph. Oh, it's supposed to be dashed. Keep forgetting. It is.
Yes.
I have to erase every single line I did.
How annoying?
I just write dashed with a line.
No, Eddie.
Me too. I wrote in pen and then I knew it wasn't. Wait, is it
Yeah,
that?
that's
solid?
That one's solid.
Solid line.
Come on, Paul.
Dashes through the line. That work?
I do that fast. Close.
Put it. It's
There we go.
This.
Just testing you, obviously, guys, right?
Of course.
Okay, now what we need is the zone that satisfies both. So the point's got to be above the parabola and simultaneously below the line. So what that gets you is this enclosed region here.
Yo.
Okay? Boom! Poggers. Wow. Wow.
I didn't know you knew Owen Wilson.
All right. Now, let's do one more. One more of these. So there's two inequalities. How about 16D? 16D. This one, we're not going to graph them separately. We're going to go straight to the, well, maybe we will. I don't know. Taylor?
Just kidding. No, she's not.
Okay, 16D. The first one, you can, you're going to be graphing y equals 1 over x squared, right? Everyone clear on that? So, dotted or solid? Dotted. Just draw the dash line. Okay. There's your 1 over x squared curve as a dash line. Now, while we're at it, I mean, we might as well make a quick mental note here. Since we're ultimately trying to solve this, would our shaded region be kind of like above or below? Let's test out a point real quick. Let's test out a point like that lives here.
3,
3, great. Is 3 squared times 3 greater than 1? Yeah, so we're going to be talking about shading up here. How about over here? How about negative 3, 3? Be careful. Same. So this region and this region will be shaded in. Try out anything down here, you're going to see that does not work, right? Like if y is negative, for example, y is negative, then this thing is negative, which means it can't work. So maybe we jot down just a really rough sketch to remind us that, okay, half of our answer is the region above the 1 over x squared curve. The second part is 1, 2, 3, 4. 1, 2, 3, 4. 1, 2. What shape is this 4 minus absolute value of x? Yep, it's like an upside down V, shifted up 4.
It's a roof.
Now, do we want to be below that curve or above it? We want to be below it, so now our overall answer is the region below the V and above the 1 over x squared, so it's these two little regions right here. That's pretty neato. So how many solutions are there to this system? An infinite amount. They all live any point you can pick inside these two little weird shapes would be a solution. What about Buzz Buzz?
It looks like a buzz buzz.
It does look like a buzz buzz.
Oh, I see.
Press oof in the chat for Veronica. That's what I say. Okay, 17. What if there are 3?
You do the exact same thing.
Nope.
Yes, you do.
Yeah,
You have to know. Because I did them, so I was wrong. I'm so mad.
It's in your opinion you do.
In
In
my,
my opinion, you do the same thing.
that's a good way to do things in mathematics, is make sure everything's in your opinion. Okay? And you're not wrong. So, yeah, exactly. It's math. So we'll do 17A. Okay, so 17A, and then after this, I'm going to show you sort of an example of how this is applied. Okay, so x is greater than 1, y is greater than 0, and x plus y is less than 4. So these are how many curves? Sometimes it annoys people that I call them curves when they're straight lines, but it is what it is. Okay, so firstly, 1, 2, 3, 4. 1, 2, 3, 4. In my opinion, if you were going to graph x plus y equals 4, it would look like this. Okay. Moreover, in my opinion, if you have to graph x equals 1, what kind of line is that? Vertical line at 1. Okay, so there you go. Good opinion, Braden. Okay, and then how about y equals 0? It's a horizontal. Okay, so now the zone, you probably already see where the zone's going to be, but be careful because you can get thrown a curveball here. The zone could be over here. I mean, that's possible. The zone could be over here. But we want to be to the, so if your x value is greater than 1, then you are to the right of this vertical line. So here, I'll just for the millions of Twitch fans at home, I'm going to draw them separately. So x greater than 1 would be the right half of this plane. Y greater than 0 would be all the points that have a y value greater than 0. And then this would be all these points below the line. So what region satisfies all 3 of those? It's this triangle here. How do we feel about that? Pretty manageable, right? Okay, so I'm not going to give you an example of 18 because I feel very confident you'll figure that out. It just says, please do not just copy like this for part B, for example, just modify it a bit. It says, write and graph a system of inequalities whose now feasible region, there's some vocab. This thing here, that's called the feasible region. It's a region of points that satisfy the system of inequalities. So for 18, you're just writing a system. I would start by drawing the system, drawing one out, and then saying, what would the equations of those curves be? Sorry, let me clarify. They're not equations, they're inequalities. So what would be the inequalities that generate that region? Okay. Last thing, then I'm done talking. We're going to do the meme number question. 21. 21. Widgets. We like widgets. So 21 says, some company produces 2 types of widgets, A and B. This month, they can produce up to a total of 1,000 widgets, but at least 200 have to be type A and at least 400 have to be type B. Write a system of inequalities, blah, blah, blah. Okay? So let's model the first bit of that first constraint. The total has to be up to 1,000. So let's use A and B. A plus B has to be less than or equal to 1,000? How do we feel about that?
Great.
Are we sure? So that says, that basically is a mathematical way of expressing that you can produce up to 1,000 total widgets. Okay, there's 2 more. We have to make at least 200 of type A. So A must be, we have to make at least, so A must be greater than or equal to 200. And B must be greater than or equal to 400. Okay? So this is what happens a lot of times in real life. It's like you're very often not solving a system of equations, right? You're not going to know, oh, we must produce exactly this number of A and this number of B necessarily. You might be seeking to like maximize your profit, but a lot of times you're dealing with like sort of a range of possibilities. So that's what we have here. So let's graph it. We're graphing it freehand, so don't get too hung up on the drawing. Let's graph this first. By the way, let's label the axes. What should this one be?
A.
A. B. So this is a line, right, that hits, make sure your graph is properly labeled. So what number is this? 1,000. This is also 1,000. 1,000. Okay, no. Okay. Then A must be greater than 200. So here's my A axis. So I draw a that 200. And then B must be above 400. It's 400. You feel okay about that? So we have to be below the diagonal line, to the right of the vertical line, and then above the horizontal line. So our feasible region is again a triangle. And then, so you can think about different possible configurations that work. Just for example, quick little example. Could we produce 350 A widgets and 500 B widgets? Is that allowed?
Yeah.
Yeah. Can I produce 700 A widgets and 450 B widgets? So, no, you violated that. Get the idea?
Wait, I have a question.
Yeah.
How do you know which one's A and which one's B on like the graph thing?
You make it.
You just
Good
choose?
question. Could we have drawn it like this?
Yes.
Certainly.
What?
It would just be, this would be 400 and this would be 200. It would have the same shape.
Okay.
You geometry lovers out there, especially Zarita, this would actually be a reflection over the line y equals x. You love reflections, right, Zarita?
They're great.
Yeah.
especially
Yes. Oh, I just got that. Like Narcissus. Okay. That makes sense, Cheyenne, though? Does that answer your question?
Yeah.
So yeah, certainly your choice of which one's the horizontal, which one's the vertical is arbitrary. Just make, as long as it's labeled, you're good. Okay. That's it. That's it. Sody pops for all. Friday, like my favorite song.